From Philharmonic Hall in Lincoln Center, home of the world's greatest musical events, another program in the award-winning series, the New York Philharmonic Young People's Concerts, under the musical direction of Leonard Bernstein. And here is Mr. Bernstein.
Welcome back, everybody, to a new season and to a new hall, practically a new hall. The walls have been changed, the seats are new, the plush is gone, and the warm color of wood has replaced the old dark blue, and all sorts of things have happened to improve the sound of our hall. And at last, I'm happy to say it works. So to start off, we're going to let you hear the new sound of Philharmonic Hall by playing for you a short, brilliant piece by Wagner. Those of you who have seen a recent film called Help may recognize this piece as the background music of one of those wild fight scenes, but others of you may simply recognize it as the exciting prelude to the third act of Wagner's opera Lohengrin. Now, one more welcome I'd like to make before we get to business, and that is to our new solo flute player, Mr. Julius Baker. Mr. Baker, would you favor us with a sample of your art? Now that's a very pretty sound, you'll admit, but what was it? A note. Was it music? Not at all. One simple note all by itself is not music. Not even a molecule of music, not even an atom. A single note is more like a single proton or an electron, which, as you know, is meaningless all by itself. You need at least one of each, at least two atomic particles in order to create an atom. And in exactly the same way, you need at least two notes before you can begin to have an atom of music. Because with that one lonely note, isolated, nothing is happening. See, it's just floating in space. But once you have two notes, you suddenly feel a relationship between them, like an electrical tension. There's already the beginning of a musical meaning. And with three notes, that meaning increases. And before you know it, you see what happened. Those musical protons and electrons, the separate notes, that is, have combined together, forming atoms, which then combined into molecules, which finally combined into recognizable matter, like this wood, or this hair, or that Blue Danube waltz. So it turns out that an atom of music is not a single note at all, as you might think, but at least two notes. And that two-note relationship is called an interval. A very important word, interval, because it's the heart and soul of music. You see, music is not made out of notes just by themselves, but rather out of the intervals between one note and another. That's why it's so necessary for us to understand this word interval. Now, everyone knows the word in daily speech as meaning a span of time between two events. For instance, they say in the British theaters, between Acts 1 and 2, there will be an interval of 15 minutes, by which they mean an intermission. So an interval usually means a measurement of time. Now, in music, we measure time, as you know, by breaking it up into meters and rhythms and bars and tempos. But we also measure other things in music, especially pitches, those separate tones we were just talking about. And that's how we use the word interval in music, to measure the distance between one note and another. Now, how do we do this? Well, let's say we think of all the pitches there are, marked out on a long measuring tape, which I just happen to have here, that reads from 0 to infinity. 0 being any very low note, and infinity being those high, high notes that only dogs can hear. Now, we section off this tape in feet, 1 foot, 2 feet, 3 feet, and so on, each foot being that lowest note repeated over and over again, higher and higher. For instance, let's take C as our lowest note, the 0 mark on our tape. You hear that? Good. Now, as we unreel 1 foot of tape, we arrive at the next C, an octave higher. Now, another foot brings us to the next C, and so on all the way up. You see how it works? Thank you, Mr. Corigliano. Now, let's say that each of those sections, 1 foot long, is equal to what musicians call an octave, which comes from the Latin word octo, meaning 8, because there are 8 scale tones between any note and its next highest appearance. I'm sure you know what I mean. 1, 2, 3, 4, 5, 6, 7, 8. That's a span of 8 notes. And that span of an octave is called an interval. And any smaller section within that octave is also called an interval. For instance, if it spans 7 notes, 1, 2, 3, 4, 5, 6, 7, it will be called a seventh. And if it spans 6 notes, 1, 2, 3, 4, 5, 6, it's a sixth. Sounds like this. And so on. And if it covers only 2 notes, it's called a second. That's a second. Now let's try something and see if you can sing some of these intervals back to me. It should be easy because you already know that the interval between the first note of the scale and the second note of the scale is an interval of the second. You hear that? Now let's hear you sing that using the words New York, just for instance. Let's hear it. New York. Perfect. All right, you've just sung a second. Marvelous. Now, from the first note to the third note makes an interval of the third. Let's hear you sing that. New York. Fine. Now let's hear you try a fifth. Listen to a fifth. No, what are we up to? A fourth. Try that. Great. Now a fifth. Good. Great. A sixth. A seventh. That's hard. Marvelous. And now an octave. Oh, divine. Well, you've just sung all the intervals in the scale. Great. Bravo. As a matter of fact, the intervals actually go on even beyond that. There's such a thing as a ninth and a tenth, but we don't have to worry about those today. Let's just stay inside our one little octave, that 1 foot of measuring tape. Now, don't forget, these intervals don't always have to start on the first note of the scale, where we've been starting. They can start anywhere. I could begin somewhere inside the octave, let's say on E, and span 3 notes up to G. 1, 2, 3. And that also makes an interval of the third. New York. Or from that G, I can play 4 notes up to C. 1, 2, 3, 4. And that makes an interval of the fourth. Now, of course, these intervals don't always have to go up. They can be descending as well as ascending. That interval of the fourth I just played you can be turned upside down into a descending fourth. New York. It's the same interval, only backwards. It's also called a fourth. And in fact, intervals don't have to be either ascending or descending. They can be simultaneous, the 2 notes played together. That's exactly the same fourth, only a simultaneous one. And here's a simultaneous third and a second. Now, this is interesting because we're getting away from melody, where notes follow each other in time, one after another, and into the new region of harmony, where notes sound at the same time. And these simultaneous intervals are the stuff of which chords are made. You take that fourth I just played and add another note to it, this one, and you've got a chord. You see? So, you see, intervals work both ways. They work horizontally, and you see that? That means melodically, one note going to another, and they work also vertically, which means harmonically at the same time. Thank you, gentlemen. Now, this is very important to remember because if you understand that one point, there's nothing in music you won't be able to understand. Let me give you a tiny example of how this horizontal, vertical thing actually works. Here's a set of intervals I'm going to play, all of them descending seconds. Those are horizontal melodic intervals. Now I'm going to play that set 3 times, and each time with different vertical intervals underneath, that is, different harmony. And I'm sure you'll recognize immediately how the musical meaning of that set changes each time. Does that sound familiar to anybody in this house? Not at all? Well, it should, because it's the pattern of our old friend Help, as sung by the Beatles. Help me if you can, I'm feeling down, and I do appreciate you being round. Help me get my feet back on the ground. Won't you please on? Nobody dared to sing. I thought you'd all come in with it. Well, you had your chance. And I've had my chance at the piano. I think it's about time the orchestra played something. And what they're going to play is one of the great classics of all time, the first movement of Brahms' Fourth Symphony. Now, this giant step that we're taking from the Beatles to Brahms is actually not such a big jump in terms of intervals themselves, because after all, both kinds of music are made of intervals, the same intervals. And if you could recognize them in Help, there's no reason why you can't recognize them in Brahms' Fourth Symphony. But there's only one other thing you should know before you can really appreciate the Brahms, and that is the idea of inversion, the inverting of intervals. Now, this is a bit tricky, so listen closely. To invert something means, as you know, to turn it upside down or backwards. So you'd think that to invert an interval, let's say this ascending second, would mean simply to play it backwards, a descending second. But that's not what inversion means at all. To invert an interval, you may play the two notes either forward or backward, as you choose, but in the opposite direction. Does that seem too hard? It isn't really. Just look. Here are those same two notes, C and D, an ascending second. Now, we invert that interval by playing the same two notes in the same order, only descending. In other words, C to the D an octave lower. And what has happened? It's not a second anymore. The interval has changed into a seventh. Now, supposing we had started with the same interval, only backwards, D to C, a descending second. Now, to invert that, again, we play the same two notes in the same order, only ascending, D to the C an octave higher. And again, it's turned into a seventh. Now, what does this mean? Simply that whenever you invert an interval, it becomes a different interval. And by the way, the new interval, the inverted one, can always be discovered by subtracting the original one from the number 9. Isn't that an amazing fact? As we just saw, a second inverts to a seventh, and 2 from 9 leaves 7. Can you follow that? And then in the same way, a third inverts to a sixth. 3 from 9 is 6. And a fourth will invert to a what? Right, a fifth, because 4 from 9 is 5. And vice versa, a fifth will invert to a fourth, a sixth to a third, and a seventh to a second. You get it? Those are all components of 9. Now, what does all this have to do with Brahms? Well, just this, that Brahms, great master that he was, built almost the whole movement we're going to hear now out of the interval of the third and its inversion, which is the interval of the sixth. Oh, you're brilliant. Now, it's astonishing how Brahms does it. And let me show you a sample or two. The beautiful main theme right at the beginning starts off with a descending third. And it's immediately answered by the inversion, an ascending sixth. Then again comes a descending third, and again an ascending sixth. Now that's a marvel of construction, which is all very fascinating to those mechanically inclined, but does it make beautiful music? Well, just listen. Quite promising, isn't it? And that's just 4 little bars of music. Now, of course, Brahms can't just stick to thirds and sixths forever. In the next phrase, for instance, he expands the descending interval to an octave. Then again a rising third, and again an octave, and again a third. And then as he goes on developing his theme, of course, other intervals come into play, fourths, seconds, and whatnot. But the important thing is that the beginning of that theme, those first 4 bars out of which the whole movement is going to be made, is all intervals of the third and its inversion, the sixth. Now let's jump ahead to the next theme in this movement. And what do we find? Again, it's almost all built on thirds. Now, could you hear those thirds? Those are thirds. That's a third. Again, thirds. A third. Third. More thirds. Incredible, almost the whole theme. Now, as this theme goes on, we begin to feel something's wrong. Suddenly, there are no thirds at all. Ah, but on closer inspection, it turns out that the accompaniment to that tune underneath is nothing but a series of descending thirds. Now, isn't that lucky? And isn't it typical of Brahms, the master builder? Now, listen to how that theme and its accompaniment of thirds sounds in the orchestra. It's like some great mad German tango. It's simply miraculous what can happen to a little interval of the third, isn't it? And so all through this movement, we come upon these intervals of thirds and sixths used in the most ingenious ways, horizontally, vertically, upside down, and inside out. And now we're going to play it for you, the whole of this magnificent, dramatic movement, which is one of the high points of Brahms' whole creative output. Somebody asked me this week, why in the world did you pick intervals to spend a whole program on? Who cares about intervals? That's technical stuff. Well, I'll admit it's a bit technical, but after all, we did decide, didn't we, that the interval is the atom of music, and what can be more important or basic than that? So let's forge ahead and get to know intervals better. Now, you remember that famous measuring tape we used before to mark off the octaves. Now, let's just consider, out of this measuring tape, one octave. That is 1 foot of the tape. And what a lucky coincidence. It turns out it's marked off into 12 inches. And there also happen to be exactly 12 notes in an octave. Now, I don't want to confuse you. I know I said before that an octave has 8 notes in it, which is why it's called an octave. But then I was speaking of our regular major scale, which uses only some of the notes that exist in an octave. For instance, as you know, the C major scale uses only the white notes of the piano. 8 of them, but there are black ones too. So all in all, there are actually 12 different notes in every octave, each note exactly the same distance from its neighbor. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And with the 13th, we're back again where we started. Now, the distance between any 2 neighboring notes is, as you know, a second from here to here. But as you may not know, it is a minor second. A minor second is the smallest distance we can move from one note to the next in our Western musical system, which is based on the 12 different tones, like the 12 inches of the foot rule or the 12 minor seconds in our octave. Now, if there is such a thing as a minor second, there must be also such a thing as a major second, and so there is. Twice as big an interval as the minor second. Now, I know this seems to be getting complicated, but I do want you to feel the difference between a minor second and a major second, because the piece with which we're going to finish our program now is almost totally made out of themes built in minor and major seconds, and the difference between them is very important, as you're going to see. Now, this hair-raising piece is again a 4th symphony, only this time by the great famous British composer Vaughan Williams. We're going to play for you only the finale, the last movement, but in order for you to relish it to the fullest, I want to show you a bit of what Vaughan Williams does with those tiny little intervals in the preceding 3 movements. From the very opening bars of the first movement, he is already presenting us with minor seconds, as if to say, this is going to be the subject of my symphony. Now, that's nothing but a descending minor second, followed by a drop of an octave. Now, to build his theme, he repeats that minor second and follows it up by more minor seconds descending from a greater height. And then even higher, he gives us two more pairs of descending minor seconds. And those four notes form the basic motive or the motto of the whole symphony. You're going to hear it a lot in the last movement. Now, in the orchestra, this rugged opening theme sounds even more rugged because while the high instruments are playing one note of that interval, of that minor second, the low instruments are playing the other. And that makes a mighty clashing dissonance. Because when that interval of the minor second is played vertically, you remember about vertically, meaning simultaneously, it makes harmony of a very bristly kind. Now just listen to the whole theme now in the orchestra with all its bite and strength. Pretty bristly, isn't it? Now, the very next thing that happens is again made of minor seconds, only this time they're rising instead of descending, like a great monster rising out of the sea. It sounds like this. You see what can be done with minor seconds. You could have all sorts of music. And so it goes. Almost the whole movement is concerned with these dissonant, fierce, gigantic uses of that tiny interval, the minor second, especially in its four-note motto form, which is this. Now, the second movement also uses seconds, minor and major, in a slow, song-like way, but its greatest moment comes just before the end of the movement, where there's a sad flute solo, mostly made of falling minor seconds. Sounds like this. And underneath that flute solo, the harmony in the trombones consists of four very soft chords, which, as if by magic, spell out the four-note motto from the first movement. Just listen. That's the harmony under the flute solo. Now listen to them together, the flute melody and those chords in counterpoint. It makes a whole network of minor seconds. Beautiful. And what a mysterious atmosphere it makes with those tiny little intervals. But then abruptly, the third movement charges in high spirits, as if to dispel the mystery. But after a brief moment, the old four-note motto clangs forth again in the brass, and then faster in the woodwinds, and then even faster in the strings, as if to show that this riddle of minor seconds from the first movement is still not solved. It sounds like this. You hear that? Now, it seems as if all the three movements so far have been bent on solving the mystery of those minor seconds that we heard at the beginning. But now in the last movement, we finally get the feeling of having solved it as it breaks in with this great jolly tune. Now, what is it about that music that sounds so solved and so liberated? It's just this, that after all the messing around with those crabbed little intervals of minor seconds that we've been hearing for three movements, we finally arrive at a triumphant tune that opens up into a major second. Now, obviously, major seconds aren't all that wide open compared to fourths, for instance, or fifths. which are really wide open, but compared to the scrunchy little minor seconds we've been hearing in every conceivable form for 3 movements, this major second seems like the gates of heaven itself. And there you have the real magic of intervals. In the hands of a composer who's a genius, a modest, humble little major second can have a mountainous majesty. And so all through this final movement, you'll hear the interval of the second used for all it's worth, major and minor, descending, ascending, in all kinds of rhythms, and combined with all the different themes of the finale in a dazzling display of counterpoint, which finally works itself up into a frenzy of major and minor seconds. But at the very height of this exciting build-up, when everything is going like gangbusters, on the very last page, the composer suddenly hurls us back into the dissonant rage of the opening movement, and with 6 final hammer blows, the symphony comes to a savage end. Now, why this sudden, brief, angry, dissonant ending after a whole joyful movement that made us feel we'd solved something at last? Well, it's as if Vaughan Williams were telling us, ladies and gentlemen, boys and girls, that's life.
from Philharmonic Hall in Lincoln Center, the 9th season of the award-winning series, the New York Philharmonic Young People's Concerts, under the musical direction of Leonard Bernstein, has opened with Musical Atoms, a study of intervals. Featured today with a prelude to Act 3 of Wagner's Lohengrin, the first movement of Brahms' Fourth Symphony, and the finale of the Fourth Symphony by Vaughan Williams. This program was recorded in Philharmonic Hall and was produced and directed by Roger Englander.